you should see on the left-hand side is the SAP screen, and what I've done on the right-hand side is a checklist of the steps I'll be going through, both for myself to keep track and for you as well to follow, since there are quite a few screens that I have to go to. This allows you as the viewer to follow along. So we're going to do the regular or standard SAP process first. I've created some of this data already in the interest of time, but you should be able to get a good feel for what the process is involved. So let's start with just the standard SAP process that you would take if you wanted to do some calibration. So I already created an equipment, and we're just going to briefly show this equipment. So this is just a temperature gauge, and there's really nothing special about it. I haven't added any information. Of course, you can add your manufacturer information, etc. But this is just very standard for our demo. We will go create one master inspection characteristic. So we've done this. Let's create a master inspection characteristic, and we shall call it temp 200. So we use plant 1000, and we call this temp 200. We'll make it quantitative. Let me release this immediately. We'll give it a description. "200 degrees. Okay, and I have to just enter some characteristics here. Control indicators. Good. And test equipment. And this gives us this field here. So let's say we want 2 decimal places. And it's going to be Fahrenheit. That's the unit. And let's say our target value is 200 degrees Fahrenheit. Lower specification limit, we can say 195 and 205. And let's say the plausibility limit of 180 and 220. So if you enter those, that's really out of spec. We'll continue, and I'll save this. Okay, so we've created one master inspection characteristic. Now, obviously, you would have to create multiple of these. I have already set one up earlier that we can now just add to. So we will change the task lists that I'm using for this. So we have a task list here for temperature gauge calibration. It is an equipment type task list assigned to this very equipment. And so here I've already, I've included already master inspection characteristics that I previously created. So the way that you want to do the calibration of a temperature gauge is typically you want to catch the value on when it's rising and then as well when it's falling. So we start with the 0 degrees as it's rising, then 100 degrees rising, then 100 degrees as it's falling. Oops, sorry. Then again 0 degrees falling. And then, of course, we have to specify it for the as left as well. So you have the same information repeated. I'm going to add the 200 degree temperature. I'm not going to insert it in between. Typically, you would set this up in sequence. It's going to be out of sequence just because of the way that I'm entering it late here. But I think it's still easy enough to follow along. Okay, and we'll do this 200 rising. Then we have to do a 200 degree falling. And then, of course, the as left rising and falling as well. So let's do this twice. So this will be rising as left. Yes, as left. unfortunately, like I said, these are a little bit out of sequence, but should still be in order. Okay, so we'll save this. Okay, we've assigned our master inspection characteristic to the task list. Now let's go have a look at the maintenance plan that I previously set up for this. We'll just briefly look at what that looks like. So this is the equipment that we used, and then here we have the task list that we just had a look at and assigned our master inspection characteristics. Other than that, there's nothing special about it. Now we'll go schedule this, and I'll start the schedule today, and I'm just going to release this first one, even though we still have some time. And then I'll save it to call, and let's go back in. So you can see now this has been started, and we can look at the actual work order, which I will record as well, just so we have it for later. So we've scheduled. So here's our work order. It just has the one operation that we defined, and then these are the inspection characteristics that will need to be taken. And let me type that in. Right. This is our inspection lot, which we will use in the next step. And so you can see all of these characteristics have been generated from our task list. We'll go out, and then we will do results recording. This is transaction QE51N. I have the inspection lot already, so I'll just copy that. And this now allows us to enter our readings. So let me expand this a little bit. In the description, we have what needs to take place, and then in the specification, we have our ranges. So as you can see, again, this is a little confusing because I have the 200 degrees down here, but you have the as left in here also. Even if, say, all of my readings are within spec and I don't actually have to go do any adjustments to my equipment, I still have to enter all of the as left readings as well. So this, as you can see, so we'll do all my as found first. So let's say we had 199 and 200 this way. So now I have to go and do the as left as well. And in this case, it'll have to be the same values from before because nothing changed. So this is a bit cumbersome sometimes. And one more. So we will now save these. You can do a valuation here. These are the ones we actually set up for QMC, but in this case we'll say in tolerance not adjusted. And this is actually part of QMC already. It requires me to enter my username and password here to sign this digitally. And then the last thing that you do in this process is you take a usage decision, and we'll just say calibration performed. Save this again. Again, it requires me to sign it. And that completes the process. So if I were to refresh this, we will see that this is now gone. So we've done the calibration. So to show the follow-up action that I spoke about earlier, in our system we have it configured to do a technically complete of the work order. I'll show that briefly. So on the work order system status here, we can see that it has now been technically completed. And we can look at the inspection lot as well here. These are all the results. And we can see here that it has a quality score of 100 because everything was in check. So that's the process you do in SAP today. Let's look at what that looks like in QMC. So we will have a look at our equipment again. So I created another equipment. It's very similar. The only difference is I have assigned this class, this Vesta calibration, and it has these characteristics. And we also, if I go back, we added a tab where you can see these. So this just says, yes, I want to use the data sheet when doing calibration on this piece of equipment. So now instead of going to create master inspection characteristics and assigning that to a task list, I will go and make a change to a data sheet that I created previously. So this is the main screen of a data sheet. You can specify some information about the equipment type itself here, if this is of importance to you, which procedure, inspection method you want to specify, and these things can then be printed on the calibration certificate. I've left it blank for now. The first thing you want to do is assign the equipment itself. So we've assigned number 892, and again, here you could assign as many as you need for this particular type. You have different functions here, and in the examples today, I only have one function, but you could have, let's say, if this wasn't a temperature gauge, but some other piece of equipment that required different types of calibration or reading. So maybe it required a reading of amps and voltages. You could have those in different functions here. So we'll have a look at this first function. In the top, you can specify some information about the instrument itself. So the instrument range, the calibration range that you want to deal with. We'll look at this linear calculation stuff a little bit later. Then we have three types of calculation types and limits that you need to set. So firstly, the plausibility limit. I like to call this the fat finger limit. So whether a value that you entered makes sense, really. So really, if you accidentally hit a key, that doesn't make sense. Then we have the adjustment limit. So if you've done your as found reading and you had to make some adjustments, you can limit or at least warn them if their adjustments seem a little bit out of spec. And then lastly is the process limit, and this is the one that is taken into account in the results recording itself. Now, for each of these, we have different calculation types. So in this example, I'm just going to do plus or minus the entered unit, but we have different variations on this. So you can do a percentage of the range or percentage of the standard. So this will, we'll see this in a further example. But this allows you to require the input of a standard, and then your actual reading is based on a percentage of that. So then just plus values, and then the other one we can do is just input itself. So this would require you to have an input value, and then you have to enter an output value, and the allowable output value will be calculated by QMC. Then this bottom section here, these, we call them sequences, and each of these is equivalent, if you will, to the master inspection characteristic that I set up earlier. So if I wanted to, let's add the 200 degrees like we have in our other example. So we'll do a rising of 200 degrees, this will be Fahrenheit. The output I expect to be 200, also Fahrenheit. And I want to actually insert this one between 20 and 30, so we'll just number this one 21. So now it is down here, as you can see. And let's add a falling reading, again for the 200 degrees. We wanted 200 the input and output, and also I want this one in between. Okay, so this will now in the inspection lot give us a 0 degree rising, 100 degree rising, 200 degree rising, and then the equivalent falling in the opposite direction. I save this, so we've done this and this. Now we'll go show the maintenance plan that I have assigned to this. This will be quite familiar from our previous example. So here's our maintenance plan with this particular equipment assigned. Now the difference here is that I don't have a equipment task list. I have a very generic task list assigned. We can have a quick look at this. So these are the operations on the task list. We have multiple operations here. Each one of these will, when it is converted to an inspection lot, correspond to a function on the data sheet. So you just need to have some extra in here in case you have multiple functions on your data sheet. And we only have one characteristic on here, and it's just a template really. It's just a placeholder in comparison to what we had previously in the equipment task list for the standard SAP. So let me just go back. So there's nothing really special except that we have only this particular task list assigned. So now let's go and schedule this. This is the same process as before. I will release this one again. And at this point is where QMC steps in and creates the inspection lot based on the data sheet information. Let's go back in again so we can look at the work order itself. Just make a note of this one again. And then this is now where the characteristics were generated from our data sheet. So I'll copy the inspection lot as well, so that we use it. And you can see here now, you have the rising at 0 Fahrenheit, 100, 200, and then the same for falling. But what you don't see here, and there's no need for it, is the as left values. And you'll see when I actually do the results recording why that isn't required. So let's go to our results recording now. So we've done this, this, and this. I have the inspection lot number copied, so I'll use that. And so here's the first difference already. You're presented with this screen where you have to specify what type of reading it is. So since we are first starting out, we'll make this an as found. And now this is quite familiar. So these are the specifications that were generated. So now I go and do readings. And I'm going to make one fail so that we do the as left readings as well. So let's say we had a -3 on this one, and the others are okay. So 200, 1, 100, and let's fail this one too. Actually, that passes, but I just wanted to have a failure. One thing that we can do here is this button, this record lab standard button, is a QMC addition. So if I press that, I have a standard that I set up previously for this. And so you can see it gives the green light, and it bases that on when this standard itself was calibrated last. So you can see the due date for this is out in the future, and it was very recently calibrated. So it is up to spec, so we are okay with this. So now I have to save this. Again, I do an evaluation. And the as found codes, yes, I want to say adjustment is required because we failed the value. Enter username, password for the signature. And then what we do is we do a further inspection here. And this time we do an as left. And now we can go and enter the as left values after we've fixed our equipment. And we'll make it pass this time, so everything's up to spec. Okay, now I could again record a lab standard here, but I will just save. Our evaluation now is in tolerance adjusted, so that means we have to make some changes to it. Sign it once more. Now, this is something you can turn off if you don't like it. And then we will do the usage decision as before, and we'll say we calibrated this. Okay, and that completes the process from a QMC standpoint. I'm not going to show the T code because it's the same as we saw before, but I will go and show you the calibration certificate. So I still have I will copy the inspection lot in here. And then I run this. And this will attempt to print, but I'm just going to print it, tell it to print, but I'll have to go look at the spool. Just say print. I'll let that run through. Okay, so typically your printer would be spitting something out right about now, but we'll go look at the spool. And so we should see one document here. And I'll open this up. And this is a very simplistic certificate. This is the standard one we deliver. I will, in just a minute, show another example of what we have done. But this is where you have, manufacturer information. The work order number is the certificate number here. You have information about who did it, what your as found and as left conditions were. I didn't enter any humidity or temperature information on the standards recording, but I could have done that. The standard that was used and the next due date on that standard, and then my as found and as left values. Again, this is not our best example, but let me show one example. So here's another example of one that we did for a customer. And you have a little bit more information. So here you have the different ranges and their specifications. My apologies. Again, when this happened, who did it, all the standards that were used, and then in this case, there were only as found values. And we even allowed them to do some remarks, etc. So this is something we can customize for the end user. So that's the standard process, and good, we still have some time. Let me show you some of the, let's call them advanced features. So the spot checking, which I mentioned earlier, this is where you require the input of a standard, and then your actual reading is based off of that. So let's look at the data sheet for this one. This is similar to the example that we just had, except we just have 0 rising, 50 rising, and 100 rising. I guess I skipped the 0 falling. But in this case, I changed this calculation type to plus or minus the standards reading. Before I had it set to plus or minus the entered unit, but in this case I have it on this standards reading. And how this will come into effect is in the results recording itself, which I've already created the inspection lot. So you can see here now, as opposed to our first example, we actually have double the amount of rows to enter. So this is because it now requires me to enter a value for my standard. So let's say my standard read 1 degree. Well, this is now going to look at the specification here after I hit enter. It will adjust accordingly. So we had said that the 0 rising is a plus or minus 2 of the standard. So if I change this to 1 now, well, that adapts the specification accordingly. So whereas before -2 would have been a valid value, it now no longer is, because it is now outside of the specification based on what your standard read. I'm not going to do the rest. it's clear of how that works. We will go and show the next type, and this is what we call reading point specific, and I'm also adding the output based on input reading. Let me just get out of here. We'll go look at the data sheet one more time. This is a different one again, although very similar. In this case, I selected this reading point specific that immediately grays out the process limit here. So I no longer have access to it here. But now instead, on each of these sequences, I can set a different reading, calculation type, and limit. So what I've done here, for example, on the 0, a percentage here wouldn't make sense. And I've made it plus minus of the input reading. And so you will see how that works, very similar to the where we specified a standards reading. And then on the others, I thought maybe a percentage made sense, so I said percentage of the input reading. So 5 and 6% on the 75 and 100 in this case. And then again, a plus or minus on the 0. So what this looks like in the inspection log that I have also generated is like this. So now again, we have 2 rows for each reading essentially. And this is similar now. Instead of the standard that we had in the previous example, it's the input. But each of these specifications is calculated according to that sequence.